Now let's see other limitations. The valence bond theory, it does not distinguish between strong and weak ligands. If you remember examples that I took in the valence bond theory, the first example that I took, this was the complex, and if you remember, I had said that pairing occurs in the environment of NH3, right? But in the next complex, even though the metal was same, the ligand has changed. In this case, pairing does not occur. Similarly, when we had done for our coordination number 4, NiCN4 2 negative, in this case pairing had occurred, but in case of NiCl4 2 negative, pairing did not occur. Valence bond theory could not explain why some ligands cause pairing and why some ligands do not cause pairing. So those ligands which cause pairing are strong ligands, and those ligands which do not cause pairing are weak ligands. So basically it could not distinguish between the strong ligands and the weak ligands. This is the next limitation. So according to the next limitation, the theory does not make exact predictions regarding the square planar or the tetrahedral structures of the complexes with coordination number 4. We have a very good example of this complex. Let us try to find out what will be the hybridization of this complex according to VBT. So according to VBT or valence bond theory, first of all you have to find the oxidation number of copper. So that's X plus 0, because NH3 is neutral, is equal to plus 2. So the oxidation number of copper is plus 2. That means copper is present as Cu2 positive. Now we have to find the electronic configuration of Cu2 positive. So originally copper's electronic configuration is 3d10 4s1. So if it's Cu2 positive, means it has lost 2 electrons. So it's going to be 3d9. So let us make the d orbitals for this. This is your 3d orbital, 4s orbital, 4p, and 4d. Now let us fill as electrons in that orbital. So there are 9 electrons in 3d. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now the last electron, which is unpaired in the 3d9, it does not have any place to go. It cannot pair up because there is no other electron left for it to pair up with. So there are 4 NH3, that means there are going to be 4 electrons and we need 4 orbitals. So those 4 orbitals are going to be sp3, because this electron has no ability to pair up because it does not have another electron with the opposite spin there. According to VBT, the hybridization is sp3, but X-ray diffractions have shown that this structure is square planar and not tetrahedral. So here, coming to this complex, VBT failed. So this VBT failed, as we have seen there were many limitations for this complex. VBT failed. It could not explain the magnetic susceptibility, it could not explain the thermodynamic and kinetic stability, and it could not give us a quantitative analysis. It gave us a qualitative analysis. So next we are going to see more theories which will help us to understand coordination complexes better and help us to remove some of these limitations which VBT gives us.